right. Now we get to do our first panel. This panel is called, we called it idea to impact. So the idea being that the ideas come from research you're doing at the university, in your labs, in your classrooms, you name it, just talking with folks and other academics. And then, but how do we make that impact happen in open source is, I think, a really, really huge way that a lot of research coming out of universities has actually made a huge impact on industry, on society. One of the things I wanted to focus on with this is I feel like there is it's not quite recognized the extent to which a lot of really big projects came out of UC and other academic institutions. And so we wanted to take this opportunity to kind of highlight a few of those. So I will let each of my panelists introduce themselves, and the first question was really to introduce yourself and provide a quick overview of why you're on this panel, basically. So, which project you're working with and how that was connected to academia, and also how you felt that the project was widely adopted, and maybe how that was impacted by being in academia. And also tell us what level the project is now. So I'm not going to introduce everyone particularly. I'll let them introduce themselves. But I'll start with me, because I'm Stephanie. You met me already. But I'm actually wanted to talk a little bit about the impact that Seth had on our ability to be cross, and a lot of the open source work being done at UC Santa Cruz, as well as, I think, a lot of things that Seth impacted. So for those of you who are unaware, Ceph is an open source storage system that is, pretty ubiquitous now. It's all over the place. It's also part of the Linux Foundation, so it's now a foundation under Linux. And it started at UCSC. Sage Lyle, who was the founder of that project, was a grad student here, was a PhD student at UC Santa Cruz, and the reason that we have Cross is because Sage was nice enough to donate money after he was able to sell the spin out of the startup that he created around Ceph. And the people who bought it was, thankfully, our Red Hat sponsors, were actually the ones who bought the Ceph, or bought the startup. And that funding really had huge impact, I feel, for open source activities on campus. We've had a number of different projects that have become either upstreamed into larger projects or been able to create communities around. No big startups yet like Ceph, but we're getting there. So anyways, I think that is, and Ceph itself, of course, is exceedingly, I think, still well used. I mean, it's huge in a number of different areas, telecom and whatnot. And again, it's part of the Linux Foundation now. And I think what's also interesting is that it still has a UCSC tie, because one of the maintainers is one of our former graduate students who was working on Ceph when she was a graduate student at UCSC, and now at IBM was one of the lead maintainers, and continues to be like part of the Ceph executive board. So anyways, that's me, and I'll pass it on to you.
Thank you, Stephanie. My name is Ben. I'm the founding engineer and the VP of technology at Alluxio. Alluxio is an open source project. It's incubated from UC Berkeley AMD lab about a little bit more than 10 years ago. So I have been involved in this process. So Alluxio is more like you can think the distributed caching system for data analytics and AI type of workloads. So today it has been used a lot by like many companies, like for example, Meta, Uber, and also Microsoft, this kind of company, to use this technology to build up their data infrastructure. Yeah.
Hi everyone. First, Stephanie and the team, thank you for the invitation. My name is Fernando Perez. I'm faculty at UC Berkeley in statistics. I'm the faculty director of the Berkeley Institute for Data Science, which is where our OSPO is housed, and Kirsty Whitaker and Jared Millman, who are here, the ones who really are doing all the hard work. And my path kind of into academia was really through open source. So what is today known as Jupyter started as me procrastinating on a physics PhD at the other UC, which is the University of Colorado, Boulder, back in 2001. And that grew into what became Project Jupyter at Berkeley. But I was a research scientist at Berkeley, and at the time, this type of work wasn't really recognized kind of as real work. I do remember in 2013, having a meeting with a well-known, actually open source developer, but at the NeurIPS conference in 2013, and this person asking me, like, okay, all these things you're doing are great, but what do you actually do for work? Yeah, all those things we were talking about, they take like 60 hours a week. So to me, they're work. But and at the time, people who were in the room, Paul Ivanov, Jared Millman, were colleagues trying to build kind of this collaborative open ecosystem that had, in particular, and I think we'll dig into that here, something very different from the traditional norms of academia, which is that no one entity owned it. It couldn't be branded. It wasn't owned by Berkeley. It wasn't owned by our colleagues at Cal Poly. It wasn't owned by any one entity. And that cuts against the grain of the traditional norms of recognition and career promotion and so on and so forth in academia. And it's taken a long time, and it's not an easy path. But at some point, I got a faculty job at Berkeley. I'm in the statistics department. And it was because, and in recognition of the value of that open source work, I'm grateful to my colleagues at Berkeley who were basically willing to kind of take a chance on a statistician who didn't know statistics or a physicist who didn't know statistics to nominally be a tenured statistics professor. And today, what I'm trying to do at Berkeley is precisely kind of push deeper the notion that scientific software, the creation of these tools, is scholarship. It may look different, but it is an intellectual contribution. It is essential to the very mission of research and education, and if it wasn't done as research and education, it wouldn't be what it is, right? The reason Jupyter is successful, to perhaps try to answer the original question, is because we use it. It is the ways, and it's not perfect, and we have problems, but fundamentally, we still use it day in, day out, and we use it as a research tool, we use it as a teaching tool, we use it every day, and that's, I think, why it's better, and no, none of these things can be built by outsourcing them. Research software is not Gmail. Research software is not Google Calendar or whatever, right, for many companies. It's different, and we have to be the ones who build it, we have to be the ones who use it, and that means it has to be recognized as real work, and I think that's kind of the core of our mission.
Thanks. I'm Tony Wasserman. I'm going to drag us back a little further into the distant past. As you can see, these people are my junior. So I'm a Cal grad in math and physics. I had the free speech movement for teaching me about revolutions. And this tells you when I was there. I'm a Cal parent. I am a Santa Cruz parent. My son is a 1994 graduate of UC Santa Cruz. And I was a faculty member, a professor of medical information science at UCSF, and a lecturer in the computer science division at Cal. And actually, Alex, there were two computer science departments. They grew up in parallel, and one of them died because they had a faculty opening in a year when there was a complete freeze on hiring. And the faculty could only agree on one person to make an offer to. That was Don Knuth. That didn't happen, of course. So they lost their faculty position, but 2 years later they all merged. So dark history. It's been more than 50 years since Unix came to Berkeley. And I mention that because it's a key starting point. The federal government, the Defense Department, made a grant to the Computer Systems Research Group to develop BSD Unix, right? To build, virtual memory and things like that on the VAX. And so what that led to was the creation of BSD Unix and the BSD license, okay, which covered the way that the software could be distributed and used. And it was a very liberal license, so you could do a lot of things with it. Meanwhile, I was working away at UCSF on a project called User Software Engineering, which was a methodology that really focused as much on outside-in user experience for a new system as opposed to the structural top-down programming that was in vogue at the time. So we built all this software, And we said, well, we'll donate it. We'll give it away to who wants it. So what did we do? We put a BSD license on it. And so I think we were one of the first two UC things to try that. And in any event, we distributed this software. And what that led to was that I left the university. I left my full professor position and started a company, Interactive Development Environments. You can find us. We're number 78 of the first 100 .coms. So that's real early. And in IDE, we took and built a lot of our own stuff, but we also used some software that came from the university, and we were second after Sun Microsystems to put open source software in a commercial product. So that history has continued. IDE existed for a long time. And so what do I do these days? Well, the university, I retired from the UC. I'm an advisor at Skydeck, the Berkeley Accelerator. I advise tech founders not to screw up. And I've done some consulting for companies in product management and open source project offices. So I keep busy these days, even though I'm officially twice retired.
Thank you, everyone. Thank you, panel, for introducing yourself so greatly. I just want to move on with a couple of questions I have for the panel. So what the agenda for this is, we'll go for a few more, probably about 20 minutes or so. I have some prepared questions, and then we're going to open up for Q&A to the wider audience. But if there's any reason that something gets said to you, you're like, oh, you have a two-finger, you have to say something, feel free to raise your hands as well too. But I think the first question we kind of talked about going over was talking about how are projects and ecosystems coming out of academia kind of different from open source projects coming from elsewhere. And this is a key issue I think that we are struggling with as part of the OSPO network, is that there does seem to be a difference about something that comes through academia and then something that's coming out from like the community or from industry itself. And I just want to ask the panel, what do you think those challenges are, or how are they different? And is it impact, you think, the sustainability and adoption of the projects? So I'm not going to just pass it. Not people who wants to answer.
I'll try. Yeah. Years ago we talked about different classes of open source software. Community software, which is the people in t-shirts who live in their family's basement and get pizza and clean t-shirts now and then. And foundation-based projects, the things that are sponsored by projects like Apache or Mozilla, and commercial, which are started by companies, increasingly venture-funded, with the idea that they're going to monetize their software. And now there's academic software. Well, it's none of the above, right? I mean, academic software, as with Jupyter and with my own work, sneaks its way out into the wider world and gets used by businesses and governments and the like. But academia, they keep score differently. If you're a professor and you build software, you don't get the same rewards. It's harder to get promoted if what you're building are software artifacts, unless you write about them and publish them in respected journals and conferences. So the way that they keep score, I think, is an important differentiator. And so people who are working in open source, we contribute time to open source project offices. We do a lot of other stuff, but you don't get rewarded for that in the same way. And you certainly don't get venture capital until you leave the university and start your own thing.
Well, I'm about to find out whether we get rewards or not. My promotion case, the full professor is sitting, the redacted version is sitting in AP Bears, and I was supposed to read it last night to respond to it, but I was too tired, and I didn't actually open the PDF, so I'm about to find, I have an unopened Pandora's box of exactly this question, because I didn't lie to Berkeley, and I didn't pretend to be anything but what I was, and I said, this is what I do, and if you want to hire me, this is what you're hiring me for. That was 7 years ago, and that's how I came in with tenure. But now I'm about to find out, what does it look like for a UC to give full professor status or not to someone who does this kind of stuff, and who has an H index that's negative, who doesn't worry about that track, who kind of ignores all of that, and who tries to work across all disciplines. And so we're about to find out. I'll let you know in a few days. But I think I hope there's room, not because I need a promotion. I'll be fine if I don't get it. But I do worry a lot about the early career folks who haven't had yet a path in science and who are doing this kind of work. Also because the likelihood of impact at the level of something like Jupyter is difficult, and that's simply a matter of luck and timing. I mean, I hope that we've done good work. I would like to think that we worked hard, but there was a big element of luck and timing. And if these kind of superstar projects, some of which are represented here, are held as a standard for saying that's what, if you do that, then you can have a career in academia, that's completely unfair, and we can't do that because many academics have successful and valuable and important careers because they publish work that 50 other people in the world understand. But that work is important and is deemed valuable and has meaning, and they can build a valuable career based on that. So this can't be a standard, right? I love working on something that happens to be of very broad impact, but the people who are building a really important tool in solar physics or in the analysis of microbiomes or in managing data about deep oceans, those people are never going to be used by Google and Red Hat and this and this and that. And yet that work is important, and they're doing it in collaboration, because the way these ecosystems came about was because a neuroscientist was working with an astronomer. So specifically, Matplotlib exists because John Hunter was a neuroscientist working in epilepsy at the University of Chicago Children's Hospital, had friends at NASA and JPL who needed tools to plot the orbit of a lander around Mars. Right? And he was willing to collaborate with them. And that kind of collaboration, right, across disciplines, where there's no single point of ownership, but that's deeply, deeply embedded in the actual work and the actual research, needs to be valued and recognized. And that is, I mean, the axes that Tony decomposed this work across are correct. I think I point in a different direction, which is this idea of deep, deep interdisciplinarity, continuous ongoing collaboration without a clear thing to point to of the paper that got the cover of Nature, but rather this kind of smooth, continuous process. It's very natural in its creation. It is hard for our systems to understand it and to value it and to account for it. And in many ways, that's kind of the work that we have cut out for us. And I think the opportunity is that as a UC, if we do make progress, not just Berkeley, but the whole UC on this, it will move the dial in many other places. Many other institutions will look at this and understand what has happened. Because junior scholars in many other places are really struggling with this. And that ultimately hurts the sustainability of the tools, right? If that postdoc who did the work for a couple of years and they were still idealistic and willing to kind of push the limits of their nights and weekends, doesn't have a career based on that work, eventually they stop. And that thing dies. And then we don't have it later. And so that's kind of where I see this.
Yeah, I'm going to talk about this from a different angle. So imagine I'm a UC graduate student. I have an open source project. So what can make this project widely adopted? Let's guess. What is the number one most important thing? In addition to have this source code hosted on GitHub, like after that, okay, what is the number one thing you need to do? Marketing. So what is the best way to market your own open source project? The number one thing, the best thing in the Silicon Valley is you have Google or OpenAI or some other big guys or the famous giant or the hot startups using your technology. That's the most important thing, okay? But that is also the hardest thing. These companies, it takes There could be months to years to prove, hey, I want to really use, to validate, and to really use or adopt your technology. So the number one most important thing is to get a production use case for an open source project, because this is already 2025. There are so many projects on GitHub. Okay, so marketing, get real use case so people can follow. That's the most important thing. So now go back to this question. What is the difference between academia projects and industry projects? For industry projects, they are born with the production use case. Okay, so whenever you have you can see a lot of use case projects. They are graduated from Facebook or from Uber, and they start to blog about this. They start to talk about, hey, this is how Uber is using these projects, how this is, Meta is using this, and suddenly they get a lot of stars on GitHub and get a lot of like people, hey, I'm just trying to follow this use case because Uber or Meta is doing this. I just want to copy how this is doing. So that will just make the adoption easier. So that's basically the pros for if you have an industry brewed open source project. But there's also cons. Okay, there's always pros and cons. So for academia created project, like for example for Alluxio, we are from UC Berkeley ANP lab. You can definitely tell if this is from university, this is a project from university, you get a very friendly treatment if you just submit talks or submit anything to meetups or to some other conference. There's a lot of industry conference, not just academia conference, yeah, KubeCon, this type of things, right? So, and they are typically pretty friendly to university-born projects. So that's another way to leverage your, basically, if this is a project from the university, from the lab, to basically emphasize neutrality. So you're not representing a cloud vendor. You're not representing the benefits or interest from a big company, but you are a university graduate student or professor. So you are perhaps the most natural position in the world. So people will also like that. So it really depends on how you are positioning yourself and to, based on where you are, you started. Yeah.
Great. It's really useful thoughts. I mean, it's very similar to some of the thoughts I had with regard, especially with regard to the fact that I feel like academia is maybe even more than other open source projects impacted by the transient nature of academia and students working on things. So I really appreciated your point about if you have the incentives or there is the rewards that a postdoc might stay or someone might stay to help work with this project. And then we're figuring out, for us, I think it's also figuring out how to make that sustainable from the perspective of like an academic OSPO. How do these projects actually become sustainable in the long term? And that's a reward in and of itself, knowing that your project is actually making that impact. And that kind of leads me to my next question for the group here is talking about sustainability. There's been a lot of focus, at least within our group at UCSC, on different pathways of ways that open source projects coming out of academia actually become the next Jupyter or the next Ceph. And that's, I think, a big question because I don't think it's really clear to a lot of academics and researchers that are working on projects the best way of doing that all the time. And it's definitely something that we're having conversations with on a constant basis in the OSPO kind of academic sphere. So I kind of would like to just hear, maybe if you can talk a little bit, we've talked a little bit about this, but maybe touch on the specifics of the pathways to different projects you've either worked on or seen going, just to give people ideas on how these became more wider adopted coming from academia. Now, in our case for Ceph, like I said, it was one of those situations where the graduate student graduated, created a startup, the startup got bought, and then integrated into Red Hat, which is now integrated into IBM, but then into Linux Foundation, and now it's actually maintained through the Linux Foundation. So that's like a pretty good success story, but not necessarily the only pathway or the most likely pathway. We've also had projects within Cross that we've supported that have been integrated into things like Apache Arrow. One of our big projects actually didn't become its own project, but actually decided to go with something that was existing, that was actually a very successful project, And that's made it accessible. Though it actually still exists, it's still maintained, it has long-term perspective, it has a long-term outlook, viable sustainability, because it's not, didn't go off on its own and become something, but actually went into that other project. So I'd like to just hear from the group here about what your thoughts on different pathways for open source out of academia.
Maybe I can start from this part.
Yeah.
Okay. So I will introduce the path for Alluxio. So about 10, maybe 11 years ago, our founder and also our current CEO, Haoyuan Li, he was doing his PhD in UC Berkeley EMP lab, and his research topic at that time is to help Apache Spark to basically speed up Apache Spark. And at that time, Spark has a lot of it's getting a lot of attention, but it also has some very notable limitation or disadvantage, like people want to really problem issues, challenges that people want to resolve. So he got one of the topics from this research topic, and he grew his own project, open source project at that time was called Tachyon. It was mostly contributed by a group of UC Berkeley graduate students, PhDs, also working on Spark, and also they worked together on this. And you can think this is more like a sister project of Apache Spark in the early days. So actually, before Apache Spark 1.0, Tachyon was shipped. It's released together and also shipped together with Apache Spark. So in this way, it quickly gets into a lot of people's attention. I think let me pause here. So I think there's two things here. One is it's solving an issue which is getting increasing importance in the community. The second one is really you get a good channel that you can let the people use or try your open source project, right? At that time, because at that time, Tachyon, as I mentioned, Tachyon was shipped together with Spark. So you can just, if you install Spark, you can just try Tachyon at that time. So later on, so that's more like a old history. But later on, our CEO Haoyuan Li, he basically he stopped his PhD research there, but just go and create a company to commercialize this open source project. So that comes to the next very important thing for a open source project to get really popular and widely adopted today. It really requires a team to work on this day and night, or full time, basically what I mean. So that is the most important thing, because especially if you're serving a lot of users, open source users, they get all kinds of issues or environments you have to set up, and also all kinds of use cases, documentation and tutorials, and make all the issues, Docker images, all these kind of issues. You have to get a team to work on that. And as a student, if you just get a student to work on that, which is sustainable maybe for a little while, but if you really want to get this into production use cases for like maybe more customers or users, it's getting challenging. It's getting challenging today. So he basically paused his PhD study and started to create his own company. And I was recruited as like a first one or two employee on the team to work on this full time. Okay. So after that, then you get all the different kinds of questions. Right? You get a venture capital back your business, and then you have to answer the question: hey, where is the money coming from to pay the paychecks for all your employees, right? It's basically the commercialization, and you can perhaps delay this problem until Series A or mostly Series B, but in definitely Series C, you have to answer the question like, how do you grow your revenue? And you have to create a business model and create a differentiation between your product versus your open source and balance these two. So this is just a whole new, a bigger problem, set of bigger problems to answer. So I guess like let's back to 10 years ago in 2015. At that time, like we created a company. There were not a lot of very successful commercializing examples of open source projects at that time. So, it's very interesting that like actually set as national laws. Yeah, at that time, I think the asset, the basic acquisition happened at 200 million, something like that, for Red Hat. But that was considered as one of the very successful cases to convince, if you want to get like a VCs to put your money in there, that becomes one of the very successful data points there. Okay. But today it's very different. This is 10 years later. You have so many companies that are running their open source projects and also products on top of these open source projects, but already listed in like they put their IPO there. So I mean the path is paved already there. So I would say like for now, if you're just running open source, getting adoption is adoption is number one challenge, and as mentioned, like get the first production use case, and then replicate this production use case to 3 or 5 or 10 is the most important thing. And in this process, you will iterate your product, your open source project. You will iterate your documentation. You'll iterate even your positioning of your software, your system, like the benefits, all the kind of messaging, right? So that is the most important thing to iterate with your customers, with your users. So I would say like the most I guess that's my lesson or my answer to your question, like how to see the path is really just focusing. I mean, in the early, I guess my answer is in the early days, it's perhaps you have to convince a lot of to the investors, but now it's really as long as you have a very successful adopted software, which means you are solving an important problem, or this is a big enough problem, like a lot of people are having, then you're building a very good foundation and leave the other problems later.
So I'll take perhaps a different tack, because I don't think not every academic project is going to have wide industry usage, and I think that's really important. That's a valid use case, but there's a lot of research in academia that is not meant to be a product that Google relies on. And so the question is really, how do these things have a path forward? And I think that's really important for a system like the UC to ask. I have kind of a very simplistic and pretty obvious kind of mental model of how open source works is there's a lot of kind of latent energy out there to potentially bring to bear on a problem, but you can't really harness that energy unless there's a bit of a stable backbone to support it. It's kind of like, it has to be a vertebrate, if you will. There has to be a backbone. Too big of a mollusk just kind of flops around and collapses and doesn't produce useful output. So the question is how to create that. And I'm going to use kind of 2 examples that are closest to the work we do at Berkeley and BIDS, which is on the one hand, Jupyter. That is a project that has a deep research and education side, but does tail off into industry use. And on the other hand, the Scientific Python coalition of projects, which is led by Jared here and Stefan van der Walt, which is really a collection of very science-oriented projects in the Python ecosystem. Jupyter is large enough that we have been able to kind of find an individual home under the Linux Foundation. We do have industry support. When we launched the Jupyter Foundation, it was launched with contributions from Apple, AWS, Bloomberg, Google, and Meta, right, the big ones, because they do have enough product based on it to be willing to put both funding and engineering time into the project. Scientific Python is a coalition of academic projects, but I think the effort that the team is making is precisely to say, well, there's solar physics, right, and there's analysis of biological data and genome data, etc. All of these projects can still work together and collaborate in order to find some of the commonalities that help them succeed and find some of that backbone of resources. That is a way of actually contributing that stable backbone of infrastructure, common things. There's actually a lot that can be done in common, and the team has been very good at kind of finding those, so that the smaller amounts of resources that may be available to, say, a solar physics project, which is a pretty niche thing. It's very important science. It actually affects everyone in the world. If there's a solar flare coming, you actually want to know about it. But it's not something that is ever going to be a broad usage tool. How do we find a way for that to find some measure of sustainability and success? And I think, in my mind, the path is precisely finding these coalitions that kind of leverage some of the models that for projects like Jupyter, but doing it in a way that maps to these kind of federated communities, such as Scientific Python. So I think that is kind of how I think about it in the context of projects that are deeper into research than things that have big industrial uses and venture capital. No venture capitalist is going to fund a solar physics project.
Yes, well, one of the things that's happened, as we've all seen, is that here in 2025, there's hardly a project that you can find in industry or in academia that doesn't have open source software in it. And that's an important thing to keep in mind, because one of the points that we heard here is that there really is a distinction between academic software or software that's built without a commercial use in mind and software that's built with potential commercial adoption and funding and the like. And when you think about that, you think about product management, you think about product roadmaps, you think about support, all of these things that companies and governments want before they'll adopt your software. So if your idea is to sell to companies or to get widespread industry adoption, you have to, as Ben said, have a team of people and ideally get some funding for it so that people can pay the rent. But now let's come back to this other category, which is exemplified by the solar system that's going to have limited use. You still want it to be sustained. One of the things that has happened over the years in open source is the development of foundations. And we've seen a lot of foundations. Linux Foundation perhaps is the best known, but there's the Apache Foundation, the Eclipse Foundation, and the Mozilla Foundation. And we could go on for a long time. And these provide a certain amount of sustaining support, and they provide a certain amount of credibility for the products. So that if your project is part of the Apache Foundation, there's some expectation that it has to meet certain standards, it has to have a team working on it, it has to have an active roadmap. And so that's a path, and maybe we'll end up with more than one such foundations that, in fact, play home to some of the academic projects that aren't going out shopping for seed money or venture capital. So I think there's a place for everything, but the one thing to keep in mind across the board is that a project, to be successful, has to fill a need that people have. And one of the things that we do not do well in software in general is to talk to potential users and find out what it is they want and what it is they need. Because you can build the software, but it's not if you build it, they will come. It's much more the question of, are you providing something that provides value and service to an audience? And if so, that's going to help your uptake, as well as the references and the presence of a support team and confidence that, in fact, that software is going to be around next week, so that companies can count on it if they're using it for some kind of a mission-critical project.
That's a very important final point from that question of like, oh yeah, if you expect people to adopt it, you better be around to make sure it's maintained. I just wanted to highlight, before throwing it out to the for Q&A, another idea, and we touched on it a little bit when we were talking about foundations, but for those of you who are maybe new to open source or working in open source projects, there are things called fiscal sponsors that are also, they're not always quite as big as, well, I guess foundations are technically fiscal sponsors, but they're also kind of a lower level types of fiscal sponsors that support projects and create, and that's also a really great pathway for many academic open source projects. And it is a great question to ask of your OSPO on campus if you have questions about that, because we're all trying to work with those. With that, and also I guess I should give a shout out, although it's maybe potentially an odd time to do that. We're an NSF project, our NSF program called the Pathways for Open Source Ecosystems, where I think a number of us have projects under, but up until recently, that's been a really, really great effort by the U.S. government to help really support open source, because a lot of what Fernando was talking about, of those projects that are important but maybe aren't going to be commercially successful or commercially viable, let's say. So that's another one to keep in mind. And again, happy to talk to anybody interested in those from an OSPO's perspective as well. But I would like to throw it up to Q&A. We have about 20 more minutes for this session, so I'll get started. Marvin, you're first.
Thanks. Thank you for. I'll introduce myself. My name is Marvin Barksdale. I am at Mass General Brigham, the health system out in Massachusetts. So I have traveled a long way to hear this beautiful, beautiful, beautiful information. We're currently rolling out and developing our own OSPO, so getting information from all of you has been quite helpful even in the first hour. I guess my more specific question is something that Tony was talking about. I'm more curious about, for Fernando and Ben as well, about foundations and their kind of appetite to support projects that, as you said, don't really have this long-term, sustainable, we're going to be a commercial entity. Because to be frank, I haven't really seen it. And I think when I talk to different foundations, whether it's Linux, their appetite is more for, let's be honest, kind of like long-term fiscal success. And instead of kind of, I think there might be an appetite and a logic for supporting some of these really valuable, more, let's use the example of digital health projects that may have a specific use case, maybe no long-term kind of strategy, but, I'm really looking for like a foundational appetite to say, it makes sense for us to support this. There's plenty of use cases out here, but to be honest, I haven't really seen it. Not sure what the question is, but just
No, I can play who do you know with you, because Bob Greenis and Otto Barnett, certainly were leaders in medical computing, and they never made most open source at MGH.
Fighting this fight right now.
The guy who was the tech lead under Barnett at MGH now writes spy novels. Which probably is more lucrative.
Yeah.
But thanks for making the trip. I'm going to be in Boston next weekend. Medical computing is its own thing. And there is out here at UCSF a big digital health effort and a group, what did he call it? I want to Health something foundation. I can point you to it, but catch me afterwards. Where they're in fact trying to do this to sustain, obviously, UCSF is another one of the larger places where medical computing is being done. So yeah, but it's essentially the same issues, but domain specific. Whereas Apache is kind of general platform. What you're looking for is there the possibility of a foundation that could in fact be funded by the Robert Wood Johnson Foundation, for example, which funds a lot of medical projects and provide a home for people who are looking for open source medical projects. That's where I would start from.
Yeah, thanks.
Thanks, Marvin, for coming. I guess we will be talking on Thursday and Friday about Jupyter Health and Jupyter in the medical space, which I think is something that has a different flavor for me. And so I think in healthcare, the fact that it is an industry with a well-established process and mechanisms for funding and something modular what's happening right now. The US is still, the business of healthcare is itself an industry. So I have a little bit of hope there. I'm going to tack back to your point about something like the Linux Foundation, and there I have a theory / hope, which I kind of already referred to, which is that in the aggregate, something like, let's say, to point to the one that I know best, an effort such as, for example, Scientific Python, right, aggregates a collection of projects that individually may not be sufficient for an entity of the size and scope of LSA to really care about. Say, to take the example that for some reason stuck in my mind, sun pipes over physics, right? But in the aggregate, that collection of projects, right, that entire collection of projects is actually relevant to one or another of the industry stakeholders at LF, because one of them has contracts with NASA, the other one's an automaker that wants data on this other thing, and the other. So in the aggregate, they do matter. And so I think it is possible to find ways for kind of this group economy of scale to effectively provide something like a tax. Like, I mean, the point of taxation is to aggregate resources to redistribute them back for common goods, like, say, paving the roads that everybody uses. In that sense, an entity like LF can potentially, or others, right, Apache or et cetera, right, could potentially provide that if we find the right coordination mechanisms between those projects. What's going to be very hard is for any random postdoc in Hungary or Scotland to go and do that by themselves. Like, well, that's hopeless. But if these communities work in a somewhat coordinated fashion, I think that's a lot of what the SP team is doing with Chair and Stefan, is I think it gives a pathway for something like this to happen with places that do have the infrastructure. I mean, LF is an engine that knows how to talk to industry. That's where we met. They know how to talk to companies. They have a process, and that engine works. So I'm hoping that we can build that connection and highlight how those things, even the specialized ones, do have value that matters to the aggregate of those entities. That's my hope.
So I have been working on different projects to engage with the Linux Foundation, but also Apache foundations. So my impression is really, I think for Linux Foundation, they have more events going on, and it helps us to connect to the users, to connect to other projects. And these are typically global events, and that goes pretty organized pretty well. So I think because we started from the big data world, and big data is very Apache heavy. It's very, very Apache heavy. But today, I think I attend most of the Linux Foundation events.
I don't think I have anything to add to this group, except that I think that it'd be interesting to see how, like a fiscal sponsor that maybe just specifically focuses on, like the way that maybe like the Python Foundation is specific to Python-related projects. So there's something that was specific that got created maybe through consortium of the big medical researchers. That would probably be an interesting way of kind of dealing with that issue. So maybe a Linux Foundation, but for medical. So, but thank you. Those are really good starts. I think Kat first, and then you. Okay.
Hi, I'm Kat Allman with Digital Science. I have a question related both to the gaining of academic credit for open source projects as well as demonstrating commercial applicability. There's a project out of the Non-Focus Foundation. Jonathan Starr is working on what's called the Map of Open Science with a goal to document all the different little projects that collectively create science in a contemporary area. Am I overly optimistic to think that that's going to be helpful?
I want to give a quick shout out to Jonathan at Dumb Focus because they're also working with us on our discovery effort for UC, and yeah, that is hope. I think a big part of that. So, but I'll let.
No, very quickly. I am hopeful. I think those things are valuable and they're important because I think efforts like that do help us tell the story. I don't know if it'll be heard on the first try, but we're never going to find out if we don't do the work of the discovery, the mapping, and it's being done thoroughly and systematically. So I'm a huge supporter of those kinds of ideas, and I think they will have an impact. It may take a few tries to tell the story, but I think that they're valuable, and a group like this can amplify that message, right? We can use that, so thanks for sharing and pointing to that, because I think collectively we do have enough of a voice to amplify that and to get it to the committees and so on and so forth that can listen. You're running the show, so.
Anybody else?
Hi, thank you for having us here. My name is Yahya. I'm from UCSC, the Schwartz Center for Computational Neuroscience. We developed EEG Lab. EEG Lab is being used by 80% of EEG and biosignal researchers around the world. The other 20% is like MNE Python and others. I have two questions. One is like, how do you retain talent in a sense that last year a publication was out for human neuroscience research, and the drug factor was one for all human neuroscience. So basically, there is one main developer for EG Lab, which I know. There is one developer for M&E Python, one developer for Brainstorm, one developer for Filtrip, and probably 2 developers for SVM. So, like, having money, if you have money, how do you attract talent and then sustain them? We used to have money from the Schwartz Foundation for about 20 years, so that's been phased out. So that comes to the second question, and I really like the taxation part of your question, of your suggestion. But my problem is that we are talking about foundations, but we are not talking about NIH and NSF, because like about a couple $1 billion of NIH's money is being spent on human neuroscience, and many parts of that is being used using like this open neuroscience work, and that we do, like EG Lab, biosignals, like M&E Python, but they don't pay anything. Basically, they use it, and then if a truck just hits these 5 people that all lead, and usually they meet sometimes every year, and then they're dead, or just they leave academia, which M&E Python, there were 3 of them, and 2 of them left for industry, 1 to Meta, 1 to Roche, I think. So then what happens to the multi-billion-dollar business that NIH and NSF is funding? So how, probably Stephanie would comment, how this funding could be, I don't know, part of the overhead, or like for the open source software that fund, like proposals are proposing to use to get to their novel applications, or how we can do something that, hey, you should pay up, we are funding multi-billion dollars, probably you need to like a cut of 1% of that can come to the open source. So that's 2 questions.
Well, I just also want to say my dean is right here, so sorry, not to put Alex on the spot or anybody else who's in leadership with regards to how we can sometimes pay for those particular folks, and I think that it's a really big question. And I don't think we're calling it the truck or bus factor anywhere. We're calling it the lottery factor, because that sounds so much nicer. Because they win the lottery, or they get recruited by Meta. So it's nicer than like watching people get run over by a bus. But it is a really good point. I know that I have my dreams, I have my hopes with regards to how some things could come about within the university, especially with us working in a UC system, of being able to create some sort of like pool of really talented and well-regarded, and everybody like rewards them, like set of research software engineers who help deal with some of these things. And though you don't have your individual person, but you have a team, and the team wants to stay. So I mean, these are my dreams, and I do appreciate that you're bringing up the NIH and NSF. I do know from what I was joking about the pose thing a little bit, but that is actually one of the ideas behind that particular thing, is to create ecosystems so that they actually keep people around and it becomes more long-term maintainable. I think so. I see what is possible. I also see what the challenges are. I'd like to hear what other folks also have to say. I'm the only one that.
I remember working on the numbers of what the federal R&D budget was years ago to basically say if we allocated 1% of the federal R&D budget, that would dwarf the resources of Sloan and CZI and everybody else in this world who actually does commit resources to this. And we were making a lot of progress, right? The White House, through OSTP, led with a lot of leadership by Shel Ganteman from NASA, got to the point of having open.science.gov, which was a federal website where OSTP had coordinated with 17 federal agencies to have formal statements on open source software at the federal level, and coordinated policies that were consistent and that spoke about community development and management and documentation and licensing and all that. Within NASA, SPD 41A became famous as the document that specified NASA federal funding policies around open source and open science. That timeline ended a few months ago. I don't know what to say today, because we're on a timeline where it's not about 1% of this or that. The entire existence of the federally funded scientific apparatus is in question. And so once that is the problem, the boundary conditions have completely changed, and the solutions that were supported by previous boundary conditions are just not admissible under these boundary conditions at this point. So the question is, what do we do now? I don't have an answer. What I am trying to think about is that what has been historically the bug of this community, which is its lack of central support, its lack of single point of strong long-term commitment, is going to have to be a feature for now, which means we are distributed, we are resilient. It doesn't answer the problem, but let's lean to the extent we can in finding ways, if one key source is gone, for other places to support, for these networks to collaborate and cooperate in different ways, to lean into industry, lean into foundations where we can, because yes, that model was great. I advocated for it for years. I was at OSCP last year talking to those folks. That isn't in the cards right now, and the devastation that is ravaging through the core of funding is such that we were a round-off error to begin with. We're now a round-off error in the loss. And so I'm going to focus on areas where we can build something that has some degree of resiliency, but the mindset for the solution is going to have to be different, at least for now. Leaning on the international nature of this community is going to be valuable, because guess what? Europe has a huge amount of talent in development of this stuff, and they care about sovereignty. The open source argument matters when you say, I want European science to have some strategic independence for core big tech infrastructure in Silicon Valley, not to put a fine point on where we are. They care about that. And there's large, deep, detailed policy documents at the EU level on how to develop open source-based infrastructure for science and government and so on and so forth. So we've been an international distributed, kind of loosely federated community for 20, 30, 40 years. Let's lean on that and figure out what to do for now, because that's where I would spend my cycles right now, rather than thinking that we're going to get a bigger percentage of a number that is disappearing. Like 1 or 10% of zero is still zero.
One more question over here.
Hi, I work for UC Santa Cruz. I had a question about a software tool where it could have multiple use cases, and some of them might be for profit, but some could be used for other use cases. But how do you find the use cases is my question. So for example, if you have a simple software tool, but it could have applications in UI, UX experience, or just even have as for even measuring productivity, like how do you find the channels to go to the right people to say, hey, do you want to try this? Would this help with your research? Would this help enhance your experiment? How do you try to find other use cases?
Well, that's a really good question. I think for each project, I feel like there's, I think for each project there seems to be a different way, because it's going to be like really your, who your audience is, like who your actual, like what sector you're working with. So I don't know if I have a good answer, and I'm more than happy to have other folks jump in on this question. But I know that what I've seen at our institute is when we work with researchers who bring in either industry, or like Cross had that, where we were able to have graduate students and postdocs working on their projects, and then we brought in industry advisors who were able to go, hey, yeah, this would be a market you should talk to. But a lot of time I feel like it's coming to meetings, talking about the stuff we had, like at UCSC, we like to have at least yearly, hopefully twice a year, some sort of event that highlights the work that's being done by different researchers, so that you can, at least within our community, discover people and then see where synergies is. I think that's one of the things that we're trying to also do within the UC network of OSPOs, is to kind of connect you with somebody at one of the other campuses and trying to understand how it might be across campus. We have one project, the Links is like an ed tech project that we're helping with and supporting, that I feel like is very, that it was finding its market by kind of talking to people and going to the right conferences and discussions. And now it's burgeoning, it's on multiple campuses. I mean, it's mainly a UCSC project, but there's other ones coming. So, but that's just for the experience I had. I feel like it's on a case, it's almost like a case by case on that. So, but yeah, does anybody else have thoughts?
No.
Right, sorry.
So I have a question.
Maybe our discourse community might be a place where we have these discussions.
Do you want to give the mic? Yeah.
And maybe, do you want to say something? You maybe know more about discourse, Laura?
Sorry.
Yeah, do we have a discourse instance now?
Yes.
Is that open for that?
Yeah, so I was gonna say, Laura's our community manager over there, and Jared was asking about the discourse, she doesn't have a mic, sorry. But yeah, we're working on a discourse channel to ask questions like that, but we can also connect with the OSPOs on as well before.
Can I add to that?
Oh, sure.
Hi, John Johnson, UCSF. There's a huge UC Tech community, uctech.slack.com, which was started by this guy next to me, but it's huge now. It's like 10,000 people. Great place to promo that. Comes with a conference, which is UC-wide, UC Tech, happening in Riverside this year. A great place to promo a product, especially something that applies to tech. Get some other campuses on board. Find your market, find your audience. Really cool communities, UC Tech.
Thank you. First, to Fernando's point about Europe, I spent 12 years working in Europe and working on European projects. Turn it off.
That one's off.
Okay, good. And there was a really simple reward system for those projects. Number one was commercialization, and number two was open source. And if you do those two things, you were golden. It wasn't publications. It was commercialization and open source. The question I have is, OSPOs to me are university level organizations. And I've noticed we tend to talk a lot about software. But there's a lot of other things that could be open. And maybe to stretch our minds a little bit, I'd like to ask about that. So, for example, various platforms, like a platform for robotic farming that could be open. And I've seen these things, right? They're open platforms. Obviously, there's software in those things. But the main point is that they are open platforms for doing things that are not about software or not about collecting data. They're about mechanical things, for example. Or we have a project in Basque Engineering, which is creating an open platform for neuroscience experimentation, right? And it involves open mechanisms for microscopes, open mechanisms for 3D printing environments in which you can grow little bits of organisms, right? So where is the conversation in that kind of open project, and how do we support and maintain those things, which are not, in some senses, easy to think about as software? How do we expand our brains a little bit around that?
Oh, wait.
Very briefly, and over time, and others might have other points. At least I can say, when I took the job as faculty director for BIDS, I gave my dean, your counterpart, a letter, and I said, I want this to be my application for the job, because that's what I want to do at BIDS. And I said, the mission of BIDS would be to be the home for open science, open source, open scholarship, open knowledge across the university, as a space where we partner with the library. Centriplicity, our open science librarian, is here on campus, but there's open access, there's hardware. And the notion of open knowledge as a collaborative space doesn't generally have its own home. Departments now have data science, they have AI, they have these things. This idea didn't have a home at Berkeley. And I basically stated in my official statement, this will be the mission that BIDS will try to provide at Berkeley. So we want to be a space for those conversations at Berkeley, and hopefully similar initiatives exist elsewhere. But I know we're over time.
Yeah, I think that's a great answer, actually, because I think that is where, as the OSPOs are actually looking, becoming the center of gravity for exactly this discussion. And sorry, we don't have time for more questions. I just want to point out that tomorrow morning session that Kirsty is running is actually going to talk about the differences between open. And we came up with a very, what the heck are we talking about when we have another way of saying it, but what open means. And I think that will cover some of the stuff that you were also just asking about. So anyways, we are out of time, I am sorry. But grab people and ask them questions.